So let's start with chapter 2. In this chapter, we will investigate together the cellular system, the global system for mobile communication, which is the GSM system. And the outline will be at this. We will start with a simple introduction. Then we will see together the network architecture, and we will investigate the network subsystem, the radio subsystem, and the mobile station. And after that, we will see what are the intelligent network subsystem added to this GSM system. So the GSM system is basically designed as a combination of the following major subsystem. We have the radio subsystem, the network subsystem, and the operation support subsystem. And here it's very important for us to see the functionalities of each of those. So for example, if we want to see the radio subsystem, okay, here, okay, what's inside the radio subsystem, okay, and after that, this is an example of radio subsystem. We will see here the base station, okay, and all part related to the features to allow the mobile network to connect to the base station over the radio interface. And we have the network subsystem, and in the network subsystem is equivalent to the core network. We see it in the previous slide, in the last slide of the previous chapter. The radio subsystem is the equivalent to the radio access network. And we have what we call the operation support subsystem, where here we have all functionalities related to the operation of the system. So let's start with the network subsystem, which is equivalent to the core network. And this network subsystem will include the equipment and functions related to end-to-end call, okay, for the management of subscriber, for the mobility, for all interfaces. So what are the main equipment that we can find in this network subsystem? We have an important functionality, which is the mobile switch center, okay, and we have the visitor location register, we have the home location register, we have the authentication center, and we have the equipment identity register. Those are what we call here the network subsystem, and we have well-defined interface with the radio subsystem or the radio access network. And as remember, this is the core network, and it communicates with the other public switching telephony network because we are in GSM. So we have circuit switched mode. Okay. So let's start, for example, with the important equipment, which is the mobile switching center server and gateway. And it's the central element of the mobile network or the public land mobile network. And it's really a classical circuit switched network because, as we said, it comes from the telephony approach. So it's circuit switched model, and it achieves the management. It's like any switching in any telephony system. And the connection between subscriber are managed by the mobile switch center and are always routed over the switch matrix. So we have a kind of connection to know at which destination the connection or the call will be routed. Okay, and even if two subscribers that have established a connection communicate over the same radio cell, we should achieve this through the mobile switch center in order to establish the connection. Okay, so what are the relevant function? The relevant function are the paging. And what's paging? Paging is the operation to find a mobile device in a certain area of the network. So when, for example, the network receive a message or a call for a certain mobile, he will try to make a paging in order to look for this mobile device and to have the area of this mobile device in order to route or to forward the call or the message to this mobile device. So the operation to locate the device is called the paging. There is other functionalities to coordinate of call set up for all mobile switch to make the dynamic allocation of resources, to make location registration, interworking function with different network, and to have handover management we will see in details. And in addition, the billing, because the mobile switch center is a core network, so and all communication will be through this mobile switching center. So that's the billing is an important operation done. Also, the reallocation of frequencies. You have some, let's say, encryption, and you have also signaling between the different interfaces, and also you could have one mobile switch center to make interface or to control different base station subsystem, and it's also a gateway to the SMS server and so on. So this is an example of the mobile switch center, and we have a well-defined interface between two mobile switch center. Each mobile switch center is responsible of a certain base station subsystem, and we have a well-defined architecture between them. So generally, now in recent network, after introducing the let's say the data, we have for voice, for all voice, we have two server. The one is the mobile switch server S, and the media gateway, which is here, media gateway. And typically the mobile switch center server is responsible for call control and mobility management. However, uh, the mobile gateway is the handles the transmission of virtual voice circuit, which is user data. Okay, that's the most today network implemented. Okay, so we have the mobile gateway to handle the transmission of virtual voice circuit. Okay, so as we said, this is the mobile switch center. Within the core network also, we have an important equipment, which is the visitor location register. From its name, it's a kind of register, so it's a database. Okay, it's a database where we have all mobile, okay, all mobile that are currently under the control of this mobile switch center, okay, and they could be a client of the same operator, or let's say, for example, a client from other operator that we have roaming agreement with them. So typically, each mobile switch center has an associated visitor registration register. So we will have mobile switching center, and we have a VLR that is associated to this mobile switch center. Okay, and those record are the copy of the original record, which are stored in the home location register. We will see an important equipment of the core network, which is the home location register. Okay, the home register location register. In the home location register, we have it's a database that we have all mobiles of the operator. Okay, but in the mobile switch center, so in the visitor location register, we have the database of all mobile under the control of this mobile switch center. Okay, why we need a visitor location register? The motivation to use the visitor location register is once is to maintain security, and this is what we call a temporary mobile subscriber identity. So it's a kind of security, because if we are able to track the mobile device at every instant, and we know the identity of this mobile device, it's a kind of uh, non-privacy respect. So that's why we can maintain security using visitor location register, and we will see how this temporary mobile subscriber identity in order to mask or to mask, yes, the real identity of the device. So in this case, the device is now using a temporary identity, and it's a kind of to preserve the privacy of this device. And also, it's an important point to reduce the signaling between the mobile switch center and the home location register. So in this case, because you have the visitor location register that contain database of all mobile and the mobile switch center control, so the number is less than the mobile that are registered at the home location register. So in this case, we reduce the signaling between the mobile switch center and the home location register, because we can communicate with the VLR for a certain functionalities. So, and generally, vendors have implemented the VLR simply as a software component in the mobile switch center. So we will find it a part of the mobile switch center as a software because it's a database. Okay. So let's see the importance of the visitor location register. Okay. As we said, when a mobile is roaming uh, into a new mobile switch center area, so we have this MSC, and we have a new mobile that entered the area of this MSC because it control a certain, let's say, base station subsystem, okay, a different base station. So the VLR connected to this mobile switch center will request data about the mobile station from the home location register. Because we have a new user that entered this area, in this case, the VLR will ask the HLR about the information of this mobile user, because as we said, all client of the operators are registered at the HLR database. Okay, so the VLR connected to this mobile switch center will request data about this mobile switch center from the IDLR, and at the same time, the home location register will be informed as to which mobile switch area the mobile station is reside. So when receiving this request, the HLR is informed that this device or mobile station is moving to the location area of this mobile switch center. So in this case, his record is copied from the HLR to the VLR, and we copy this record and the new mobile switch center, and is then removed from the VLR of the previous. So in this case, at the HLR, so we know that this device, which is A was in, let's say, this is the previous VLR. Okay, when receiving the request from the new VLR, the HLR will update and will say that A now is with the new VLR. Okay, so in this case, the 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 home location register will know that the station A is under the control of this mobile switch center, but the home location register will not be aware about the exact position or the precise position of the mobile device. So in this case, the function of the visitor location register is as follow. As we said, he will work with the home location register and authentication center. So before accepting to register the mobile device within the visitor location register, he will authenticate it. He will be sure that it's a legal client and he is, or if it's a moving client. So after that, he will accept and he will control the allocation and the cipher key and so on. And the important part is the allocation of the new temporary mobile subscriber identity. So this temporary mobile subscriber identity will be used by the visitor location register at the location area of the mobile switch center. And this is a temporary, so only the visitor location register know this temporary identity, and he is aware about the the exact location of this mobile device, but under this temporary identity. So the visitor location register is not aware about the exact identity of the precise identity of the real identity of the device. So in this case, it's a kind uh, of uh, privacy preserving. So the home location register know the real identity, but he know that the device is under the control of the VLR or this mobile switch center area, but the home location register is not aware about the exact position. The VLR is aware about the exact position, but using the temporary identity and not the real identity. Okay, so this is how we preserve the privacy and we secure the identity of the device to avoid tracking or monitoring the position of or to follow or to track the device. Also, the visitor location register will support paging, as we said, VLR will support the paging based on the temporary identity. Okay, and he can track the state of all mobile station in its area based on their temporary identity. Okay, so I hope that it's clear for you how visitor location register is working. And if you have any question, please you can ask or you can send me a message about that. So the home location register is now clear for you. It's the database that contain all data related to all subscribers, and it's the reference database of subscriber parameters. We have the various identification numbers, the addresses, the authentication parameter, the services that you subscribe, the special routing information. So your contract, your agreement, your right based on the service you subscribed with the operator are all at the home location register. And in addition, you have the current subscriber status, including the temporary roaming number. So the home location register will know, okay, that this user A is now under the control of this VLR with this temporary, but the HLR is not aware about the exact position of the mobile device. Okay. So, when the HLR interact with the mobile switch center, it interact for the different procedure regarding the routing of call, to transfer, to charge, and everything, to call termination, and so on. And also for location register, the location registration is also performed by the HLR. As we said, at each time, the mobile user or the mobile device is moving from one area to another area, or from one mobile switch center area to another mobile switch center area. In this case, the HLR will update, and this is what we call location registration. Another important equipment, which is the authentication center. So now we have the core network or the network subsystem. We have the mobile switch center. We have the HLR. And we have, as we said, the VLR. It's implemented as a software part within the mobile switch center, but it could be a separate device. Okay. And the authentication center is connected to the home location register. It also could be considered as part of the home location register because the objective is to make an authentication parameter. So the ciphering key that are used for security to encrypt your communication through the cellular communication and are generated using the authentication center. And we have that the authentication center will contain the individual key per subscriber. It's as you know, when you have your SIM card, there is some, in addition to your identity, your numbers, there is some, let's say, subscriber key, I subscriber that are used for encryption. And those key I are also at the authentication center. So it's a copy of the key I on the SIM card of the subscriber. And for many operation and during the establishment of the call, the subscriber is identified by using this key. That's why you cannot make a call if you don't have your SIM card or your electronic SIM card, because you need this key, subscriber key, in order to be identified by the network, by the authentication center. And the importance of this is that we can ensure that the subscriber identity is not misused by any third party. Another equipment is the equipment identity register, and it's also a database that's used to store the international mobile equipment identity. And you know, this is the identity of the mobile, it's of the device, EMEE. And this is used in order to create different lists. And you have the white list, for example, that contain the different international mobile equipment identity that are known to have been assigned to valid mobile station. This is category of the valid equipment or genuine equipment. And you have what we call a blacklist. In this case, the blacklist could be, for example, reported as stolen. And you have the gray list that contain mobile that have a problem, for example, faulty software, wrong make of equipment, and so on. Now in Lebanon, for example, إذا حدا إجا على المطار بيزيدوا له الايكويبمنت له، يعني عمليا they are adding the IMEI على the equipment identity register to be able to use this device on the network here in Lebanon. Okay, so this is a number of the equipment. Okay, so this will give the all part of the network subsystem, the mobile switch center, the VLR of this mobile switch center, and we have HLR, we have authentication center and equipment identity register. And we could have, this is MSA, VLR are responsible for a certain base station subsystem. We have another MSA, mobile switch center, MSC, VLR, that are responsible for other base station system, and so on. So this is the core network, and as we said, is responsible to the communication with the other network, like public switching telephony or internet in case of data packet switching domain. And there is a well-defined interface between the different equipment, and those interface we define how the data are exchanged in which format and at which velocity and so on, the signaling how it's done. And we have also a well-defined interface between those equipment and the base station networking, the base station subsystem or the radio subsystem. So let's move now to the radio subsystem or base station subsystem. And in this radio subsystem, we will deal with the two main components, typically the radio interface, and we will see the base station equipment or the base station subsystem. Okay. So it's an important part, the radio subsystem. That's why in GSM we should detail them, and we will study them in the next chapter in order to be able to make dimension and to make the design of the cells, okay, planning, for example. In Europe, GSM was initially specified for operation in 900 megahertz, and now we have also 1,800 megahertz that are used also. Okay, and for 900 megahertz we have uplink direction 890 and we have downlink direction from 935 to 960 megahertz. Typically it's a bandwidth of 25 megahertz. You split it to 124 channel. The bandwidth of each channel is 200 kilohertz. Okay, as a 200 kilohertz each channel. So in those are used in the band 900 megahertz, where there is another band which is from 1710 to 1785, and this is for the uplink. This one is for the downlink, and here we have more channel because we have 75 megahertz. If we divide them over 200 kilohertz, we obtain around 374 additional channel. Okay, so that's why we have more channel with a bandwidth of 1800 megahertz. Okay, and those are the channel that we will use them to transmit data, and we will see the radio interface in details. So the radio subsystem include the equipment. So we have the user equipment, we have the radio, and we have here the radio subsystem. And in this radio subsystem, we will see some equipment that achieve the connection between the users and the core network. So the objective of the radio subsystem is to achieve the communication between the mobile station, the mobile device, and the core network, the mobile switch center, and so on. And here we will find the base station controller and the base station. So we could have different base station that are controlled by the same base station controller. Okay, so typically we talk about base station controller, and here also in the radio subsystem, the mobile station is considered as a part of the radio system, the radio subsystem. In third generation and fourth generation, we considered it as a user equipment. Okay, so let's start with the mobile station, which is the user equipment in the future generation. It's called user equipment, and now it's the mobile station. So in GSM, the mobile station is a part of the radio subsystem, and it consists of mobile equipment and SIM card. Okay, and generally it includes the radio equipment and the main machine interface (MMI) that users need in order to access the services provided by GSM. So it's a kind of terminal that allow the user to use the services provided by the cellular system. Okay, so that's why we have the mobile equipment. Here is the mobile equipment. What we have is a kind of processor. We have different interfaces, like example screen, keypad, microphone, and so on, alarm, and so on. And we have the radio equipment, which is the modulator, and we have the power management, we have the battery. So those are the different components of the mobile equipment, and we should insert the SIM card in order to have the mobile station. Remember that the SIM card it's an important part in order to be recognized by the network. So the primary function of the mobile station are to transmit and receive voice and data over the over-air interface of GSM. And the different functionalities include signal processing, encoding, error protection, encryption, modulating, the transmitting signal, and so on. Okay. And the mobile station, how it's working, when you turn on a mobile station, typically he should look for a frequency, and after that make a kind of time synchronization. So the mobile station automatically tune and synchronize to the frequency and time slot specified by the base station controller. And when it's synchronized, we have the exact synchronization. Will adjust the adjusting time advance. We will see together what's time advance in order to be sure that we receive the information at the base station at the exact time. So here what we call time advance. Okay, remember this term that we will explain it in details after. And the mobile switch will monitor the power level and signal quality, and he will define the bit error rate of the receiving data, and it's typically done for 6 surrounding bits, because as you know, we have to check the quality of the received signal from the current cell and from the neighboring cell in order to see at certain time if it's possible to make a handover or to move to another one or not. Okay, so the measurement, as we said, are results from the mobile station on downlink and surrounding base station signal level. And typically they are sent and processed with the base station controller. And after that, the system will list the best cell handover decision. And as we will see them in details in the handover, because we have here, let's say a base station, okay, and we have a mobile here. The mobile will be able to receive the level of signal from the home base station or the camping base station and the other neighboring cell. And at certain time, if one of them, according to the handover criteria, is better, okay, in this case, this will trigger the handover to this best cell and so on. What are the power level adopted at the mobile station, at the device? In GSM, those are the values. So typically the power is between 0 and 2 watt, but we are not using the exact value, we are using level. This will allow us to send, for example, a few numbers of bits in order to specify the level of power. So that's why if we have, for example, 5, it means 2 watt. If we have level 10, it means that 200 milliwatt. If we are using level 16, this means that is 13 milliwatt and so on. Okay, this is in GSM 900. In GSM 1800 power level, we are using those value, and each of one is with this value. And in GSM here we have maximum of 1 watt of power. Okay, so typically 1 watt. 8 watt, it's rarely used, really rarely used. Okay, typically when we talk about GSM, we deal with 2 watt and less than 2 watt. If you have level 0, 1, or 2, so typically it's 8 watt, but typically most of operators are using 2 watt. Okay, so we described the terminal equipment. Let's see together the SIM card. And it's a kind, it's a kind of small chip that contain an integrated circuit with a microprocessor and random access memory, and also a read-only memory. It's inserted in the mobile station unit by the subscriber when he or she want to use the mobile station to make or receive a call. It's also come in a modular form that can be mounted in subscriber equipment. Now you know that we have eSIM. I don't know if in Lebanon we have eSIM, but in different other countries it's possible to have electronic SIM, and you are able to use all services within this eSIM. It's an electronic without this chip, without this integrated circuit chip. Okay, so it's an important part because without a SIM, which is a subscriber identity module, you will not be able to use a cellular system, okay, or your service. You need the SIM card, the SIM, and the mobile equipment in order to use the services provided by the mobile network system, okay? So the GSM can route, call, and perform billing based on the identity of the subscriber rather than the mobile user. That's why SIM is very important, because if you change your SIM from one device to another device, you will use your services without any problem. Okay, because all billing and services are provided based on the identity that is integrated or given by the information, the key on the SIM card. Okay. The international mobile equipment, the identity number identify the mobile equipment, and we have other number to identify the mobile subscriber. So please, we will see together now different numbers that are used in cellular or in mobile network system. One of them, as we said, is the key that's inserted or that's integrated on the SIM card, which is clearly identify the identity of the subscriber according to the subscribed let's say services, and to achieve billing and so on. And we have the International Mobile Equipment Identity, which is used just to see if this equipment is with the white list to be used or no. If it's blacklist, it will not be used. And we have other numbers that are used at the mobile network system. As we said, the International Mobile Subscriber Identity, the Mobile Subscriber ISDN number, and the Temporary Mobile Subscriber Identity. Okay, let's see together what are those numbers. We start by the International Mobile Subscriber Identity, which is authorized to each GSM users. It's a kind of identity of the users. Okay, it contains the mobile country code, the mobile network codes. For example, in Lebanon, we have for Lebanon, and we have the operator in Lebanon. It could be Alpha or MTC, and we have PLMN unique mobile subscriber numbers. And this is not hardware specific, and it's stored in the subscriber SIM card and also at the home location registers. Okay, and it's really the key of all information about the subscriber. It's not the telephony number that we are using to call. It's a kind of identity numbers, okay, which is used to identify the subscriber. Okay, and typically it's like this. We have 3 digits for the country, 3 digits for the operator, and up to 9 digits to for each subscriber. Okay, and typically it's 15 digits. Okay, and for example, in Lebanon, the code of Lebanon is 415. Okay, the mobile network code for Alpha is 01, for Touch is 03, and the operator are known as MIC1 and MIC2. We have also Ojero is known as an operator, is listed one of the operator, and here we are using those for the different mobile network. It's for GSM or UMTS or even LTE. Okay, so as we said, the international mobile subscriber identity is a very important identity, but it's not the phone number. Huh? It's not the phone number, it's the identity. Now, I want to talk about the temporary mobile subscriber identity, which is the identity used for security reason to avoid broadcasting the international mobile subscriber identity over the air interface. And typically, as we said, this temporary mobile subscriber identity is provided at the VLR level, to maintain confidentiality. And we have a correlation between the TMS and the international mobile subscriber. We have this correlation occur during a mobile subscriber initial transition within the mobile switch center. And then the temporary mobile subscriber identity has only local significance, that is within the VLR and the area controlled by the VLR. So the structure of this can be chosen by each administration in order to meet locally. Because it's local, so each operator could define this VLR temporary identity according to their specification or to their administration. So the essential is that at home location register, we have the international mobile subscriber identity, okay, and we could have the mapping with the or the correlation with the TMSE, but we are not aware about the exact position. The exact position here at the VLR, we know the temporary mobile subscriber identity, and we know the exact position, but we don't know the real identity, the international mobile subscriber identity. That's why it's possible to achieve privacy preserving in this case. And the third number, it's the mobile subscriber number, which is the ISDN number. And it's the number that the calling party dials in order to reach the هذا رقم التليفون العادي اللي موجود معنا. So it's used by the land network to route call toward an appropriate mobile switch center. And typically we have a part which is the country code. we have the national destination code, and we have the subscriber number. And هيدا رقم التليفون in Lebanon. The code of the country is 961. The mobile operator it's 3031 3233 and so on. وبعدين بيجي رقم التليفون. وهلا صار في عندنا national destination code. It could be 71 72 73 and so on. Okay, so this is the mobile station ISDN number. Okay, it's very important for you to understand the difference between those three numbers. Okay, those three numbers are used to offer the services over the mobile data network. Okay, I hope that it's clear for you. We can move now to the base station subsystem. In the base station subsystem, we have the base station controller and the base station as a station. And here we have the base station controller. Okay, together base station controller with the BTS. We could have base station controller for more than one BTS. Together, we call them the base station subsystem. Okay, base station subsystem with the mobile user and the radio interface, we call them radio subsystem in GSM. Okay, so the base station controller, perform all part related to the radio resource management. So we have the part related to control the base station, enter cell handover, the reallocation of frequency, power management, time and synchronization in the frequency, everything related to the time delay management to control frequency hopping. So all functionalities related to this part are done by the base station controller. For the base station itself, it's the base transceiver and receiver station, and it's the visible part of the network because we can see it on top of any building or somewhere. And here can cover areas up to 35 kilometers, and this is the macro cell in rural area. And the main functionalities are to encode, encrypt, multiplex, modulate, to make the transcoding and adaptation rate. We will see how this is done. The time and frequency synchronization, voice communication, time advance. Here it's an important part because we should be sure that if, for example, we have different frequency, let's say here we have different frequency, F1, F2, and we have slotted area. And for a certain user, this slot is reserved for this user. So time advance should be done in order to be sure that the traffic of this user will arrive at the exact slot at the receiver. Okay, we will see it in details. And we have different configuration. We could have single site, single cell, single site, multi-cell, multi-site, multi-cell. Here we could have different configuration, okay, of the base station controller. As we said, we have one site, and we have base station controller to control this site, which is one cell. We have multi-cell. It's, for example, 3 sectorial cell, and we have also 1B SC to control them, and we could have multi-seat and multi-cell case. Okay, and if we want to see together what's the transcoding and rate adaptation unit here, remember last year when we presented the encoding, the voice encoding, we say that it's possible to have, for example, voice encoding at 16 kilobit per second or at 64 kilobit per second. Let's say if we are using a classical encryption, for example, here the transcoder take 13 kilobits per second, okay, and change them to 16 kilobits per second by inserting additional synchronization. So if we have, for example, data rate of voice connection with arrival data of 16 kilobit per second. Okay, here it's possible because we are at radio interface. At certain level, here we can use 16 kilobit per second. Here we can use 16 per second. But in a classical telephony, we don't have 16 kilobit per second. You know that PCM will be 64 kilobit per second. So we need, if we are communicating with, let's say, other systems, to have what we call transcoding and rate unit. And in this case, the 16 kilobit per second will become 64 kilobit per second, and after that we continue to have the bit rate as 64 kilobit per second, and this is in this direction. In the reverse direction, if it could arrive with 64 kilobit per second, and the transcoding and rate adaptation unit will decompress it to 16 kilobit per second. Okay, it's an important part because it's possible to you to put the TRAU between the base station controller and the mobile switch center, and it's also possible to use it here between the base station and the base station controller. And in this case, you need to have also 64 kilobit per second here. Okay, so this is according to the design of the system. Maybe it's better to put it here because we can use here in this case only 60 kilobits per second per subscriber, okay, or per communication. At this level, we will see the intelligent network subsystem. In addition to the voice provided by the GSM service or a GSM network, we could have additional services. They could be, for example, postpaid service, or with a new logic or location-based service, or prepaid service. Okay, because I'm talking about GSM. Now for you, they are not intelligent, they are a classical service, but in comparison with the GSM when started in 1990, in the mid of 1990, we consider them as an intelligent service to have, let's say, prepaid services. So instead of receiving a bills once a month, you have prepaid subscriber with an account with a certain services, and at each time you are using these services, and it will be updated and so on. So it's considered as intelligent services at the mid of 1990. The last part of this chapter is the operation and maintenance subsystem, and here we will see the operation. It's an important part. Okay? It's an important part because it includes all operation and maintenance of GSM equipment. Okay, and support the operator interface. Okay, and it's connected to all equipment because it's OMC, operational and maintenance, so it's connected to all equipment. And generally, it's possible if you have a small network to have one OMC. If we have a big network, according to the country, it's possible to have a global and centralized management of the network with the different OMC. It's according to the size of the network, okay? It's possible to have more than one OMC per operator according to the size of the network. So typically in OMC, we have the maintenance, the regional management of the network. We have the system change control, all software update and revision and configuration, all alarm regarding to any problem. Let's say if you have some problem or some, let's say, loss of connection in certain area, at OMC level, we are able to detect them and so on. So here we can also have at OMC some, let's say, troubleshooting services or troubleshooting functionalities in order to detect the problem and to try to resolve them. And the OMC is really an important part of the cellular system because there is a lot of information are collected and analyzed at the OMC level in order to take a decision or to take, let's say, actions to have good services in the mobile network. So this will end chapter 2. I hope that you can review this part. Okay, it's very important for you to review this part because in next chapter I will go into details to see the GSM radio interface. The GSM radio interface, we will study them in details. We will cover the different channels that are used. Okay, I will explain in detail what's the timing advance and why we have this 35 kilometers of the macro cell. And then we should make some exercise of dimensioning, okay, and to see how this dimensioning is done and how we can make planning. Then we will see the different location area because we said that the mobile switch center is responsible of certain area to be controlled. So we will see together what are the different location area and how handover is done between them. So this second chapter will give us, let's say, good knowledge about the main part for GSM, okay, and will give us an important, let's say, concept of dimensioning in cellular system and planning them. Okay, so if you have any question, please don't hesitate to send me, and we can discuss about them. Okay, thank you, thank you. So the next session will be chapter 3.